All right, let's talk about one of the most powerful parts of Python. Every programmer has a toolbox, and Python's is just packed with these fantastic, ready-to-go tools for managing data. We're going to open that toolbox up and see how you can use what's inside to write code that's not just smarter, but a whole lot cleaner, too. So picture this. You're building a new program. You've got numbers floating around, you've got names, maybe some user records. It's just this big collection of stuff. How do you actually hold it all together in a way that makes sense? You need some way to group these values. And that, right there, is where data structures come into play. So here's our plan. We'll kick things off with why you should even care about this stuff. Then we're going to dive into the big four, the super flexible list, the unchangeable tuple, and then the powerful duo of sets and dictionaries. And to wrap it all up, we'll talk about how to pick the perfect tool for whatever job you've got. Okay, so why do data structures matter? Well, at its very core, it's all about grouping values together. It's so fundamental that the official Python tutorial dedicates all of Chapter 5 to what it calls compound data types. Basically, these tools let you stop juggling a bunch of separate variables and start organizing them into neat, meaningful collections. And these aren't just some optional add-ons. They are baked right into the language itself. Having these standard tools right at your fingertips is a huge part of what makes Python code so often feel clean, so efficient, and surprisingly easy to read.
First up, let's talk about the list. Seriously, if your data structures were a workshop, the list would be your trusty do-everything adjustable wrench. It's hands down the most versatile and common tool you'll reach for to hold an ordered collection of items.
In Python, you just use square brackets, pop your items inside, separated by commas, and you've got a list. But here's the absolute most important word you need to remember for lists: mutable. And mutable just means one thing. You can change it. You can add things, remove them, or swap out the items that are already in there. And this is where that whole mutable idea really clicks. Take a look at this example straight from the Python tutorial. A list of cube numbers. Wait a second. See the mistake? 4 cubed is 64, not 65. But because lists are changeable, it's no big deal. We just target that item by its position, that's index 3, and we assign the correct value. Boom, fixed, right in place. And making those changes is so easy because of all these useful methods that come built in. You need to add a new user to a waitlist? Just append them. Need to put a bunch of names in alphabetical order? Sort does it for you. Python just gives you all the tools you need right out of the box. Now, let's say you want to build a new list, maybe the first 10 square numbers. The classic way to do this, and it works just fine, is to start with an empty list, loop through your numbers, and then append the squared value one by one. It gets the job done, but, it takes up a few lines of code. But check this out. There is a much more elegant, more Pythonic way to do it. It's called a list comprehension. Look how clean this is. We can do that exact same thing in a single, super readable line. We're basically just saying, give me x squared for every x from 0 to 9. And poof, Python just builds the whole list for us. And hey, don't just take my word for it. The official docs say it themselves. And when they say concise and readable, that's not just about making your code look pretty. It usually means your intention is way clearer, and that often leads to fewer bugs down the road. This is what modern Python is all about. So if lists are your go-to for data you know you're going to change, what about for data that you absolutely don't want to change? Well, for that, we grab the tuple. If a list is that adjustable wrench, a tuple is like a wrench that's been forged from a single piece of steel. It's a fixed size, and it's not changing. A tuple looks a lot like a list, right? It's just values separated by commas, often wrapped in parentheses. But its defining feature is the total opposite of a list. It's immutable. Once you create a tuple, that's it. You can't change it. Its contents are set in stone for life. And this slide just shows that difference perfectly. Over on the left, we edit our list of cubes. No problem at all. But on the right, when we try to do the exact same thing to a tuple, bam, Python throws a type error. It's literally protecting that data for you, enforcing that rule. This cannot be changed.
So you might be asking, why would I ever want something I can't change? Well, this immutability is fantastic for data that should be constant, like map coordinates or fixed settings. It also makes tuples amazing for stuff like sequence unpacking, where you can assign all the items in the tuple to separate variables in just one go. It's incredibly clean and super useful.
All right, we've got 2 more major tools left in our toolbox.
Now, while lists and tuples were all about keeping things in a specific order, sets and dictionaries are designed for something totally different: uniqueness and mapping.
So let's start with the set. A set is basically like a bag of things. You can throw stuff in, but the order doesn't matter, and you absolutely cannot have more than one of the exact same item. Its whole purpose in life is to maintain a collection of unique things.
And check out how simple this is. If you try to create a set with duplicates, like we're doing here with 2 apple strings, the set just ignores the extra one. It automatically makes sure that everything inside is unique. This is so good for things like, say, getting a list of all the unique visitors to a website. And last but not least, we have the dictionary. The best way to think about a dictionary is like a real-world dictionary or maybe a filing cabinet. It doesn't store items in a numbered line. Instead, it stores values that you look up with a unique key. Here's a perfect example: a simple phone book. The names are the keys and the phone numbers are the values. Now, if I want to find Jack's number, I don't have to know what position it's in. I just use the key I already know, Jack, and it instantly gives me back the value. It's an unbelievably fast way to look up data.
So we've looked at 4 really powerful tools. But, being a great programmer isn't just about knowing the tools exist. It's about knowing exactly when to use which one. So let's do a quick recap.
So how do you pick? It really just comes down to a few simple questions. Do you need an ordered sequence that you're going to change later? Use a list. Need that sequence to be locked down and constant? That's a job for a tuple. What if you only care about having unique items, and the order doesn't matter at all? A set is perfect. And finally, if you need to look up values super fast using a unique key, like a user ID or a product code, a dictionary is absolutely the way to go. And it's worth knowing that while dictionaries used to be unordered, in modern Python, they actually remember the order you put things in, which is a fantastic bonus.
You see, choosing the right data structure, it isn't just some minor technical detail. It has a real impact on how clean your code is, how efficient it runs, and how easy it is to debug. So the next time you sit down to code, just ask yourself, what am I really trying to do with this collection of data?
And that's our tour of Python's core data structures. If this explainer helped you out, please do me a favor and hit that like button. It really does help the channel a lot. And subscribe for more deep dives into Python. Stay tuned because our next explainer is going to be all about Python modules. For more tutorials on Python and a bunch of other languages, make sure to visit www.plus2net.com. Thanks for joining me,